Now, for 3-axis enhancements, this is a pretty good enhancement here. If you look at where the arrows are, we're looking at horizontal roughing, and we're looking at the clearance plane tab in the cut transfer method. So the clearance plane definition in this example is set to automatic. And then below that, we have the cut transfer method set to Skim, but we've also added a checkbox here to include the in-process stock in the calculation of the Skim clearance. So if you look at the arrows over here, you'll see that in the areas where the tool had to transverse above the part, it applied the Skim clearance to the highest position on the part. But if it didn't have to span over the part, it calculated the Skim clearance based on the cut level. So if you see these small retracts right here and over here, that's what happens when you have this checkbox checked. This just an enhancement to help you maximize your machining time. If you have a rather complex part, as you can imagine, or may have run into, there's a lot of retracts up to the full clearance when it didn't need to be.
Oh, another note, actually in previous releases, we were looking at the part geometry, only the part geometry, and we computed the Skim clearance. So what Don is saying is absolutely correct in that the Skim clearance moves will reduce your moves all the way up to the retract plane and thereby enabling faster machining. But what this enhancement does is it actually also introduces the in-process stock in the computation. So if you had a roughing operation done previously and there were chunks of stock in where you have the arrow that on this picture, let's say there was actually an in-process stock on the way. In previous releases, the system would have ignored the in-process stock and actually collided with the in-process stock. Now what it does is actually takes into consideration the in-process stock, and it would retract to the correct distance to avoid the in-process stock as well. So yeah, not only are you getting better, higher speeds in machining, but also much safer speeds now since the in-process stock is being considered.
Yep.
Thanks, Don.
Okay. So this was the cut transfer method where we mentioned where let's go into this and look at the actual clearance plane. So in the clearance plane definition, we have the clearance plane definition set to automatic, and then we have the cut transfer method set to Skim. Well, as we discussed in the slide previously, when you set it to Skim, the Skim was calculated based on the maximum extents of the part in the Z level. So the tool was always retracting up a little bit past the part based on the Skim clearance. Well, that is some wasted moves if you're machining in an area that doesn't transverse across the part. So let's go ahead and take a look at some of these look at this by cut levels here. So we're going to just work our way down. You'll see in the, at the top level, pretty much everything is based on the cut level of the in-process stock, basically. But as you get down deeper, you'll see that the clearance, the retract clearance gets larger or more distance, higher up, I should say. It's always clearing the top of the part. Well, now if we go down in some of these other cut levels, you'll see over here, it didn't need to go all the way up past the part, so the Skim clearance was applied based on the in-process stock, which is the cut level, this cut level right here. So it extended up, skimmed the top of the cut level, okay? And you'll see that a lot in some other cases. Here's another, you'll see these here. No need to extend all the way up past the part in these types of conditions. So you can imagine if this is a relatively simple part, a very complex part, you could virtually save minutes, if not more, in the machining time by not having to retract and transfer all the way up to the Skim clearance above the part.